address you. Today's evening is Professor Muller and you. I'm here primarily on behalf of Institute and on my personal behalf to accord a very warm welcome, a very cordial one to Professor Muller and his wife. I would like to convey to you, sir, that we were just trying to explain to you what is Techkriti'. You possibly by now would have understood. We are very proud of having this brilliant set of students here. Extremely energetic, extremely innovative, and they are bundles of energy which only needs to be directed towards the right direction. They know where to go and how to proceed. Only at times we have to tell them that don't digress too much. The way they conduct the functions is something really to see and believe. The entire student activity of this institute is conducted by students in Ghana with very little assistance from the faculty quarter and also very little financial support. The entire event of Techkriti' is organized by the students in Ghana, and they possibly would share with you the galaxy of experts who have addressed on this podium for this particular function. So today we are proud to have you with us. I'm particularly happy for my young friends here because they just finished their examination, mid-semester examination yesterday. So today is the right time for them to enjoy your talk. So I don't want to stand between you and them. All of you, please enjoy a very, very exciting talk that Professor Muller is going to deliver. Thank you and welcome, sir.
Thank you, sir, for your kind words. The forte of Techkriti' lies not only in its
Thank you so much for this very, very warm welcome. It is a great honor, a pleasure to be here. It's particularly nice to bring my wife Rosemary, who's been married now for over 50 years. And it's our first trip to India. And I wanted to go to India for a long time. And never quite made it. It's on the other side of the world from California. It's great to be here. Oh, I didn't get you up there. I didn't. It's been fascinating. It's wonderful to see how this country is developing and coming along. It's actually been a great experience. We love the food, the people. We've gotten to meet all sorts of people, mostly students, and it's wonderful to see the diversity of students and to see how thoughtful they are and how smart they are. It's a great future, particularly for people in technology. I think this is going to be, it's a wonderful thing to be, and I'll be talking about that. We love to be, when I came to India and you see the way the women dress, it's so wonderful. The color, the painting. I've never had a crush on so many 60-year-old women. They dress so beautiful. They remind me of peacocks. And then you look at the men, they can dress like peahens. So, today, what am I going to talk about? Can we take the lights off the stage here so this is easy? The type has changed a little bit over the years. What I'm talking about right today is going to be what I am doing today. I'm not going to talk about what I have done over the past decades. I'm going to be talking about what I am engaged in today. I retired 7 years ago. And since then, I've been working 3 times harder than I ever have. One of the wonderful things about physics and technology is you get involved in work that you love so much that you never really retire from it. And I don't think, the only thing that I won't retire until I die. But we're really involved in some very exciting things. The topics are global warming, air pollution, the future of energy, and a new theory for the physics of time. And it's not going to be easy for me to cover all of these topics in the time allocated, but I will do my best. Let me just see if I can set the clock to 0 so I know where I am. Now, one aspect of my talks is I don't like to repeat things you already know. I will, but I hope to pepper them with things that come as surprises. There's a statement by a famous humorist. You may have heard, it's one of my favorites. The trouble with most folks isn't so much your ignorance, knowing so many things that ain't so. So at the end of this talk, I hope you will have a sprinkling of things that you used to think were true, and now at least there's a seed of doubt. You're not supposed to trust me on anything, because this is science. All I can do is to point out something, say something, and then you can check to see that I was right. And of course, because scientific audiences do that, I try to be very careful. But as technical people, when I talk to a general audience, they trust me because someone told them to trust him, or because I sound trustworthy. But you are technical people. You have a particular responsibility on these technical subjects. If you read something in the newspaper, and then you tell someone about it, maybe a parent, maybe a friend of a parent, they will trust what you said because you're a technical person. And if all you did was pass on the information that you got from the newspaper, then you are not following your duty. When you say things, recognize people will respect you because you're a technical person. You're an engineer, you're a physicist, you're a scientist. And because they will listen to you, you have to be more careful than other people. You can't just pick things up from a magazine and pass it on and then just leave it like that. You have a responsibility to look at. You have a responsibility to know about these things. Not just the things in your field, not the things in your narrow field, not the thing you're focusing on, but anything you talk about. And you have that capability. I'll show you a bunch of numbers here as we go on. By the way, that figure in the background is a photograph that I took in Beijing. I call it Beijing sunrise. Well, it says sunset. It actually was a sunrise. I have to change that. Represents one of those filters, which is air pollution. And although we're going to talk about global warming, I'm going to begin with air pollution. We got into air pollution through global warming. My daughter and I started an organization together, a nonprofit organization, to study global warming. And once we reached our conclusion that global warming was real, that it was caused by humans, and that we should do something about it, we started looking at methods to approach that solution. And remarkably, this is where we got its tie-in, air pollution. We traveled to China, now I'm traveling to India. I'll tell you a lot more about air pollution, maybe even some things you didn't know. Air pollution is a recognized problem here. Our organization is called Berkeley Earth. Our website is berkeleyearth.org. You go there, and one of the things I did in preparation for this meeting is work with the scientists we have on Berkeley Earth to try to get a good estimate for how many people die of air pollution in India. We had previously published a number in a referee journal for China, but we wanted to address India too. So we put this together, and the number turns out to be the one down there. 1.1 million excess deaths every year. That's 3,000 deaths per day. When you think about other things in the world, when you think about, oh, maybe you'll hear about some terrorist attack, and maybe 30 people were killed, and this is horrendous, and it will be headlines day after day after day, and for maybe a week, and then it'll come back once a week. And those numbers are so tiny compared to the number of people dying in India every day. This is not a really disputed number. We've done this number independently of anybody. World Health Organization has been publishing previous numbers, similar numbers, 3,000 per day. In China, the number of people being killed by air pollution, typically heart attack, stroke, every day is 4,400. Why is it lower in India? Is it because your air pollution is less? We put a map online every hour of air pollution around the world. Earth.org. Click on air pollution. You'll get this map. Not all countries report their air pollution in great detail, but India does over most of the country, except for a gap in the middle that I really like to fill in some part of the south. Right today, the air pollution in India isn't so bad compared to China. Look at the U.S. and Europe. Europe is actually a little bit better than average. But this air pollution is a new kind of air pollution. It's called PM 2.5. How many people here have some rough idea of what I mean when I say PM 2.5? Raise your hand. Okay. Remember this moment. In the future, PM 2.5 is going to be a very big issue around the world. It already is a big problem. It is the greatest environmental disaster in the world today. And the scientists know about it. The general public doesn't. PM 2.5 stands for particulate matter. It's just the dust that can be sulfur dioxide, among other things. 2.5 microns is smaller. The significance of the 2.5 microns is that when you breathe this in, it doesn't get trapped in the lungs. It gets all the way into the blood. And that's where it does its damage. You'll notice that today, our region of India is not as polluted as is China. Typically, New Delhi is more polluted than is Beijing. It's a typical result. I look at this every day. Why are there fewer deaths in India? The population is almost as big, and in 5 years you'll surpass China in population. So why? The reason is you're looking at your population, and you're less susceptible to heart attack and stroke. It's not a very good reason. Like 3,000 a day. Just think of that number. Every time I see some news report of people being killed in a boating accident or some refugees from Syria or something like that, I say, and yes, and 4,000 people were killed today in China and India. Greatest environmental catastrophe in the world today, the public isn't yet taking real note of it. Partly because it is in the developing world. Something that has to be done. Let's look at close up. The great smog of Delhi during Diwali. So this is our map from that day. We'd really like to fill in this region here. Oops. I'm clicking my computer by accident. I didn't realize this was hooked up. Someone hooked up an antenna to it. Unplug it. Oh, let's go back. So, pretty bad pollution. Fireworks from other burning very visible. One of the worst day we've ever seen in India. But it's nothing like the worst day we ever saw in China. When we saw this following date, by the way, in this map, everything that's green is healthy. Everything that's brown is hazardous. That's where you don't even want to go outside. And inside is still bad. Air pollution inside is typically half as bad as it is outside. So it's still very unhealthy inside. This happened, and this must be a computer glitch. air pollution suddenly over all of China? What could that be? And we searched with a computer glitch and couldn't find it. And finally, Robert Brody, my scientist in North America, said, listen, have you checked the date this happened? Turns out it was Chinese New Year. You look at what happens with the fireworks. My daughter's reaction to this is, I didn't realize that we had such a great measure for fireworks in the country. Now, in the United States, she's looked at maps of the 4th of July, and we see the worst places where the air pollution are, and that's where she wants to go next year to see the fireworks. So, this was 2 hours ago. There's nothing. But every hour you can do it. So looking about air pollution, well, where does it come from? This is still highly debated. People in New Delhi say that it comes from automobiles. The old-fashioned air pollution did, that's sulfur dioxide, that's nitrous oxide, ozone. But this new kind of air doesn't come just from automobiles. The worst kind, I believe, comes from coal-fired power plants and coal-fired industrial energy use. Coal. What can we do to get rid of coal? Solve the air pollution problem. Quick word about renewables. This is what I think is obviously the right answer. And here's a place where your technical expertise is absolutely essential. Suppose someone says, we need 10 gigawatts of solar power. In fact, let's build a plant that has 10 gigawatts of solar power. We could build that instead of 10 nuclear reactors, right? No. There's a little bit of salesmanship in renewables. When you build a solar plant, it is always specified in terms of the capacity of that plant. That means how much power will it produce at noon when the sun is right overhead, shining right on the solar cell. But it doesn't shine at night. So if it's a 10 gigawatt capacity, it's more like a half a gigawatt, I'm sorry, 5 gigawatts on average. Well, and also sunrise and sunset that day, and the cloudy days. So on average, if you have a 10 gigawatt capacity plant, you have to divide by a factor of 6. 1.8 gigawatts. Beware of this. People enthusiastic about solar energy sometimes say that it's cheap because we don't have this power, but the sun doesn't shine all the time. Here are the conversion factors. So solar, one 10 gigawatt solar plant using photovoltaics is actually 1.8 gigawatts, 2 gigawatts. Wind power is only on about 1/3 of the time. So its capacity is 3.3 gigawatts. Nuclear is on 90% of the time. New nuclear plants are on 90% of the time. So beware of renewables. Here's another question for each of you. Again, I don't want you to shout out the answer. I want you to think. This is one of these things that maybe you know something that ain't so. Let's find out. So, of the energy produced in China, of the total energy consumed, not China, India, the total energy consumed in your country, what fraction of it currently comes from solar power?
3%.
No, don't say it. Quiet. Each of you are supposed to think about it. Is it 20%? Is it 1%? Is it somewhere in between? The answer is 0.06%. These are not disputed numbers. These are numbers you can look up. These are numbers that, as people who are not afraid of numbers, very useful for you to know. If solar is going to solve the pollution problem in India, it has a very long way to go. 0.06%. To your non-IIT friends, you can explain that's 0.0004. But it's tiny. One of the possible solutions is natural gas. And there's a great deal of misinformation about natural gas. It's one of the things we have studied in great detail in this nonprofit organization, Berkeley Earth. Let me give you one key fundamental fact about natural gas. This is a number I'm not going to ask you to guess, because there's no reason why you should know it. But there is a reason why you should know it. This is this. If you look at the particulate matter, that's this column down here, third from the bottom, or natural gas, it doesn't matter what the units are. The key thing is from coal, it's 400 times greater. You switch, or instead of putting a new coal plant, you build a new natural gas plant. And the emissions of particulate matter will be down by a factor of 400. Natural gas does not produce these deadly particles. It's a key reason why, if you are concerned, and all you should be concerned about air pollution, that natural gas plants should be built instead of new coal plants. But there's another aspect to this. If you look at what's happened in the United States, and I'll show the plot in a moment, the United States has been replacing coal with natural gas. As a result, the carbon dioxide global warming emissions of the United States is actually going down. That's because natural gas, it's much of its energy, it's CH4. And you get some of the energy by the C going to CO2, but some of the energy from the H, the four H's become two H2O. And they don't contribute to global warming. So you have 1/2 to 1/3 the global warming result when you go to natural gas. Now think of this. What this means is that if you switch to natural gas for the reason of air pollution, your contribution to reducing global warming is enormous. And that's, you get that for free. My belief about global warming is that what we need to do is address the air pollution around the world, particularly in China and India, but also with much of the world, even in Europe. We don't have not too bad in the United States. We need to address it. If we address it by getting rid of coal, replacing coal with something else, that the benefits will be enormous. Of course, to do this, the thing you replace it has to be economic. India has the fastest rate of economic growth of any country in the world right now, 7% this last year, beating out China. China's in a pattern, and now 5 to 6%. This is a wonderful thing, and it's so evident when we come here to India and we see people being so much better off than they are. Whatever we do to slow global warming, whatever we do to stop air pollution, we must not interfere with that enormous economic growth. That is far more beneficial than the dangers of any of these things. But can we do it? Yes, I believe we can. Now, people will say, let's follow the example of China. Here's a little bit of things that many people know that ain't so. New York Times headlines, China is a renewable powerhouse. They say 28% of electricity comes from renewables in China. Renewables are the future. Why can't we do that here in India? Why can't we emulate that in the United States? We should emulate this wonderful thing being done in China. Why? There's multiple headlines, not just in the New York Times, but in professional magazines such as Nature and Science. So here's a little look below the surface of that fact. Let me show you the pie chart for China's renewable powerhouse. So there it is. And yet solar is 0.06. Okay, a percent. In India it's 0.04, a little bit better than India, not much. A tiny fraction. What are the renewables? Wind? Well, wind is up there, it's 5%. This is 5% of their energy power. Most of it, most of the so-called renewables are hydropower, which is 20%. So when they say China is a renewable powerhouse, what they really mean is they have enormous hydroelectric dams. Now, I don't know how any environmentalist can be favor of large hydroelectric dams. I can show you a little bit about what they've done in China. The Three Gorges Dam in China, biggest dam in the world, produces something like over 10 gigawatts of power. They displaced 1.2 million people. They destroyed 13 cities, 140 towns, and 1,350 villages. These are their numbers. They say this is what they had to do to make this renewable source of energy. However, they say that the 1.2 million people, every single one of them to a person, volunteered to do this. That's something they can do in China. Anywhere else in the world. And now they want to develop new dams that will do similar damage to the entire Southeast Asia and Mekong Delta. When they say China is a renewables powerhouse, and you realize this is what they're referring to, it's not something that anybody would like to emulate. Hydropower is not a benign future. So here's that chart again. Okay, so renewables are way, way behind. What are the possible solutions? Let me first talk a little bit more about climate change. Iconic images of climate change, global warming, the Nobel Prize for making a compelling movie about climate change. And there's the iconic picture of the poor polar bear who is dumped from the receding ice. I'm skeptical about global warming. We were actually asked to help the country of Bangladesh decide what they should do to counter global warming. And my reaction was, I wasn't even sure global warming was what the IPCC said. Skeptics had raised what I thought were valid issues, and until those were addressed, how do we advise the country on what they should do? So my daughter, Elizabeth, we were working together with our consulting company. She was the CEO, she's a scientist. She suggested that what we do is do an independent study of global warming. We raised money, mostly independent of the government, and did that study. It took about 3 years. Independently, we addressed all the issues raised by the skeptics. As a former skeptic himself, I'm now very capable of talking to skeptics and showing them why global warming is real and is caused by humans. The plot we produced, this is our result. I'm very proud of this. This is our plot of global warming. All the way to 1750. Because we go so far back in time, we are able to move out that solar variability, changes in the sun, contribute no more than 5% to this rise. Volcanic eruptions give those big dips, but to the rise, they too contribute less than 5%. The curve that fits it all, the curve I've drawn there, is carbon dioxide increase on the Earth. Without elaborate models and addressing all the systematic issues raised by the skeptics, we have concluded global warming is real, caused by humans. And I'm very good at convincing skeptics. I like to talk primarily to influential skeptics. I had my audience yet with President Trump, but maybe we'll do that. Many people think, why do we bother doing this? Global warming is obvious. I see it every day. Not so. Let's look at this plot, but focus in on the last 50 years. In 50 years, the temperature has gone up by less than 1 degree Celsius. Is that something that you can notice every day? Well, okay, maybe not. In fact, I believe, well, let me show you. I had people write me and say, they're skeptics. The reason I'm a skeptic, he says, is because in my town, the temperature's actually gone down. I write back and say, yeah, and I can show you about 12,000 locations around the Earth where the temperature's gone down. Let me show you a map of the United States. I should have done this for India, but I didn't think of it ahead. This looks at global warming over the past 100 years. Every red X indicates a location in which the temperature has gone up. Every blue circle indicates a location in which, in 100 years, the temperature has gone down. Thousands of locations. It looks like the blues dominate, but in fact there are more reds than blues. Reds win by a factor of 2 to 1. At any one location, you cannot measure global warming because the local variability is so great that it completely overwhelms this 0.9 degree temperature rise. By averaging hundreds of locations, you can see the global warming. We average 30,000 locations. You have to average it in the right way, and we do that. We're very careful about that. But any individual who says, oh, global, it was a hot day today, that must be global warming, it's just not being scientific, it's not following your engineering standards. You are technical people. Qualitative things. This local storm probably happened, this hurricane, this typhoon. Oh, the weather has been different than I remember when I was a kid. About 50 years ago, the temperature was less than 1 degree cooler. It's really not having that big an effect. But it is real. And let me come from carbon dioxide. Let me show you 2 plots here. This is the emissions of the United States and the emissions of China starting in 1960. You see China is a developing country. It's been shooting up mostly from its energy use. They build a gigawatt of coal plant every week. 1 new gigawatt of coal every week. Again, you can be misled by the headlines. If you read the headlines, you will see China is cutting back on coal. So you say, oh, they're doing the right thing, we should follow their example. China, in the latest 5-year plan, had more than 1 gigawatt a week that they were planning on producing. Their 5-year plan was supposed to limit it to 1 gigawatt a week, so what they did is they cut back to the 5-year plan. They cut back to what they originally wanted to do. A gigawatt a week, that's like 1 big nuclear reactor a week, and it's coal, which produces the worst air pollution of any kind of energy production. So China is shooting up, and the result is that China now is twice the of the U.S. China is the biggest, the U.S. is second, third is the European Union, fourth is India. But I'm looking forward to India's growth continuing. This was from an article I wrote in the Wall Street Journal several years ago. Down at the bottom, you see the contribution to global warming from the United States. Green is from all of the developed countries. The red is from the emerging economy in India. What's clear is that global warming of the future is going to come from China, India, Malaysia, and the developed world. That's simply an engineering fact. It doesn't assess blame. I want to see the economy of India and China continue to grow. It's a very good thing. But if we're going to address this issue, cutting back in the United States cannot do very much. The United States, if we go, here we are going along, and let's say in 2020 we cut zero. It's maybe CO2. Spending lots of money. What will that do? It means the rise in the two will drop by a little bit. And then because China, India, and the rest of the developed world is developed in less than 4 years, emissions will be back in work. The United States is no longer in control of global warming. China, India, the developed world is in control. This is not just the blame. It's simply an engineering issue. If you're going to stop global warming, you have to do something in China and India. What can you do? I'm not going to say force you to do anything. I don't think that's right. I think what the United States can do is to set a good example and do things that show that you can continue economic growth while cutting back on carbon dioxide. I have a catchphrase: if it isn't profitable, it isn't sustainable. The reason is, in the developing world, you need profitable technologies because you can't afford to spend money. China did a lot of subsidies of solar energy, and they can't afford to keep it up. It's not sustainable. So they cut it out. And now one big company after another in China is going bankrupt and out of business. It's a very small amount, 0.06%. And unfortunately, I love solar, but it just isn't going to solve the problem. Let me talk about climate change. I talked about global warming, but what about all these other things? These are the sort of things you see in newspaper headlines: increased storms, increased variability, the glaciers, increased droughts. Oh, you see the icon of the poor solar bear who is losing any land, any ice he can land on. These things are largely incorrect. Global warming is real. It's caused by humans. Those are scientific conclusions. My non-scientific conclusion is that this is the correct I should dedicate my life to solving. But most of these other things are not scientific conclusions. They are what scientists say when they want to scare you or scare your friends so that you will get involved in global warming. And this is a whole talk that I give. Even the sea level rise, Bangladesh, it's not going to be flooded. There will be a little bit of flooding. But the maps you have seen of 1/3 of Bangladesh under the sea don't stand up to scientific scrutiny. You can do it yourself. Go online and get a topographical map of Bangladesh. And the IPCC, the sea level rise has been 10 centimeters in the last 50 years. It may go by 20 centimeters, maybe even 30. Put in 30 centimeters and see how much of Bangladesh it's flooded. It's a tiny thing. So there's a great deal of stuff out there that people don't know. And one of the causes is outdoor. Interesting thing happened. Al Gore wanted to distribute his movie, An Inconvenient Truth, to every school in the UK. And one parent objected, said, this is a propaganda film, this is not a science film. It was brought to court. Experts came into the court. The judge, a high-level judge, made a ruling on Al Gore's film. What he said was that, yes, former Vice President Gore could distribute this film to every schoolhouse in the UK, provided that he accompanied it with a list of 9 major errors in the film. Big headlines in the UK. Most people don't know about it. But there are other issues that come up. This famous thing in the IPCC that said the Himalayas are going to melt by 2035. It was not based on science, even though it was in the IPCC report. This was a major embarrassment to the IPCC. So there's valid reasons for people you know to be skeptics. Not a Chinese conspiracy like my president thinks, but there are valid reasons. So when you are arguing that global warming is real, make sure you don't make a mistake of passing on something you read in the newspaper, but to see whether it is really valid or not. Hurricanes do not increase, and I personally have measured the variability in temperature. And as things have warmed up, does the variability increase? No. Will it in the future? Maybe. Some of the models say it will. That's a speculation. We don't really know. The models aren't very good at something like that. But it hasn't happened yet. The number of droughts, the number of floods is not going up. There are things in this case that most folks know but ain't so. Let's look at nuclear power. This is an article I wrote in the Wall Street Journal. Most people in the United States consider nuclear power to be dead. They're concerned that our new President Trump seems to like nuclear power. It's causing a little bit of panic. They thought they'd killed him. This thing keeps on coming back. Like Rasputin keeps on coming back alive. China is building 32 new nuclear plants. India has a program being opposed by many people. Here's the problem you have if you are in India, in Malaysia, in many of these countries, and you believe nuclear power is a good thing to do. It will help solve air pollution and also global warming by providing cleaner energy in coal. If it is so good and so benign, why isn't it being developed in the United States? That's really wrong. I think all the reasons that people put forth in the United States are basically ones in which the politicians don't know enough about nuclear power to feel that they can defend it in front of the audience. So they just stay away. They're letting nuclear power die. And if not for the air pollution in China and India, maybe that's an okay solution. But we urgently need clean sources of energy. Solar is so fun. Why don't we develop nuclear? There's several arguments. One is that's really expensive. Another is Fukushima. And a third one is we have nothing we can do with nuclear waste. Let me address each one of those issues. Too expensive. Nuclear power plant is very expensive to build. But then, once you build it, the fuel, uranium, actually costs less than 1 cent per kilowatt hour. It's really very inexpensive. It's a small thing. It's 1% of the cost of the power you live in. And so, uranium costs went up by a factor of 2 or 3. It wouldn't make much difference. And if you double the cost of uranium, the amount of uranium goes up tenfold. We are not running out of uranium. Here in India, you have huge amounts of thorium. The only reason for you to develop thorium is because you don't trust the rest of the world to deliver you uranium when you want it. Because uranium works just fine. Now, you don't have that much, but you have lots of thorium. Thorium reactors are new. I think they're very good. I think they can be developed. And so it's your choice. You develop uranium or thorium. I would just suggest you develop both. So the cost is not really an issue for nuclear power. In fact, the nuclear power plant in the United States is expensive. It costs 2 to 3 times as much as one in South Korea. And I can go into some detail on that. It largely, they're deeply safe. Most of it has to do with the way it's regulated, the delays that objectors can put in, causing the price to shoot up. But if you can do it for half the price in South Korea, you can do it very expensive. Well, what about Fukushima? Fukushima is an exquisitely well-mapped disaster. This is a map of the radiation that was done by Japan with help from the United States. We know the radiation pattern in Japan. We know the levels of radiation very well. We also know the population. There was an evacuation in this region. We know how many people have been exposed. We also know the relationship between radiation and death. So the first question, this is the easy one. How many people have died so far from radioactivity released at Fukushima? Don't shut it up. Just think the answer. Many of you have to know the answer. How many of you are confident you know the answer? It's actually it's a famous number. 0. And nobody disputes this. People died from the automobile accidents that evacuated. People died from being away from their homes. They haven't been allowed to go back. But nobody has died from the radioactivity yet, thanks to the evacuation. How many people will die in the next 70 years? They picked up radiation. We know how much they picked up. And we know the relationship between radiation and cancer. Some people dispute that. The disputes are small. We basically know how much cancer is caused by radiation. And so you can do the calculation. You put your friends and family might not be able to do it. You take a map of the population, you take a map of radiation, you make it into a grid, you calculate the average doses, and you add up the doses, and you find out how many people will die. So we'll die. They haven't died yet. They will die. So I've done that. I'm not going to ask you to read those numbers quickly. You thing is the bottom line. In 70 years, 28 people will die of cancer because of Fukushima accident. Surprising number? Not really big. Will such an accident ever happen again? No, it will not. This accident occurred because a tsunami hit this nuclear reactor. One of the largest tsunamis ever recorded in Japan hit this nuclear reactor, and the nuclear reactor had its emergency power system down at a level lower than the reactor itself. It was flooded and didn't work. So this is all being fixed around the world. How many people died from the tsunami? We know we've calculated 15,000 died from the tsunami. The speculation is maybe as many as 20,000. So why are people worrying about the radioactivity? Because people are afraid of radio. They don't realize we are radioactive. The chairs you're sitting in are radioactive. I had a student. He won an award for being the best student athlete in the country. And he was invited to a special dinner. And here was the president of not the U.S., but of the organization who gives this out. And he was sitting here, and I was sitting here. And the president was saying, "So, John, I understand you took Professor Muller's course." "Yes, sir." "Well, Steve, can you tell me something you learned from it?" So he looked at the president. He said, "Well, sir, that glass of wine you're holding, it's radioactive." Then he said, "Moreover, it's required to be radioactive. If the U.S. government determines it's not radioactive, then it is illegal for you to consume it." He said, "You're joking, right?" He said, "No, sir." "Hey, can you explain this to me?" He said, "Oh, yes. Well, wine in the United States is required to be made from grapes and fruit. Grapes and fruit are organisms that absorb their carbon, all their carbon, from the atmosphere. All of the carbon in that alcohol comes from carbon dioxide in the atmosphere. Carbon dioxide in the atmosphere is radioactive with carbon-14, also known as radiocarbon. And that's because shower down on it, keeping it radioactive. But if somebody illegally makes wine out of fossil fuel has been buried for hundreds of millions of years. If they make wine out of that, the radiocarbon is all decayed away, it's not radioactive. So the U.S. government actually, this is true, measures the radioactivity of suspect liquor, and if it is not radioactive, then it is shown to have come from hydrocarbons, and that's illegal. It's actually happening. So, it was one of my proudest moments when I stood totally confused and surprised. The radioactivity is surrounding you, and it's part of our lives. But people don't realize that, and that's part of what they do. What nuclear waste storage problem? Well, how do we get rid of this stuff? Well, that's something I've been working on too. Those of you who follow me work know that nuclear waste is put in these fuel assemblies. And our idea is to take a fuel assembly, put it in a canister, and then drop it into a deep well. What kind of a well? The kind of well that we use for natural gas and for oil in the United States. We go down 2 kilometers, gradually turn it until it's horizontal. We go into a shale formation, and you can go another 5 or 6 kilometers. It leaves plenty of room. 3 or 4 of these wells that hold all the nuclear waste in one nuclear reactor. How do we know it's safe? What if there are earthquakes? Well, this shale gas has held natural gas, methane gas, highly volatile methane gas, for tens of millions of years. It just demonstrates that these are very stable. So we're proposing this, and we're starting. What we'd like to do is basically do it. The radioactive waste doesn't have to be stored for millions of years. The radioactivity drops dramatically. Once several hundred years are over, it is only slightly more radioactive. Any of that was removed from the ground in order to make the nuclear reactor work. So the radioactivity is not so super large not when you know that the ground already has radioactivity in it. So we could easily store it for hundreds or thousands of years. In fact, in the proposal we have, put it really deep underground, would be safe there for tens of millions of years. By that time, it would be far less radioactive than the radioactivity that was in the ground. So I've been talking about global warming. I've been talking about air pollution, how we supplement air pollution, we get global warming for free. And the way to do this is through, I mentioned natural gas, I mentioned nuclear power, and the third one is energy efficiency and energy conservation. That's actually the biggest one of all. We waste a great deal of energy, and we can be more efficient with it. These topics are tied together. The solutions that we see are, as I said, nuclear power, natural gas, and energy efficiency. And the issues with nuclear ones, where you have an essential role to play. For many people, you are the technical expert. You are the one who should help you. You're here at IIT. It's a very super special position, as you know. On any technical issue, they're going to ask you about it. You have a responsibility to do your homework and give them thoughtful answers and answers that you can stand by. You have to check the numbers, you have to read about it. Don't just depend on just the articles. The best thing you can do to address air pollution is to be a thoughtful, knowledgeable expert on nuclear power, gas, conservation. Now, complete change of topic. Because it turns out I'm working on something else. And those of you who follow me at Core know about this. Time has nothing to do with nuclear power. Nothing to do with energy conservation. It's an abstract thing that it's been bugging me my whole life, ever since I was an undergraduate, learning the elements of relativity theory. It's something strange with time. And once again, the problem is partly what people know that ain't so. For those of you who read popular books on time, I should let you know, I disagree with most of the popular books. They draw a connection between the flow of time and something called an increase in entropy. And I'm not going to take the time to explain it. I'm very low on time anyway. So let me just tell you that that's the thing that ain't so in this field. And knowing that, that's not for decades. Always bugged me. And finally I decided, let me write up what I know about time, and let me trash entropy as a theory. Now, I would write a popular book, and I did, called Now. The process of writing that book was a fascinating experience, because it really forced me to put everything I knew together, and in the process of checking my facts, which is something you engineering students and physics students and science students need to do all the time. Don't be embarrassed to check your facts. You gotta check your facts, because people will trust you. And checking my facts, I learned a lot of new things. And suddenly, the main thing that bothered me about time, the answer became that and that's the problem. In relativity theory, you pick the coordinates, x, y, z, and t. T is the fourth dimension. Now, if you go into this coordinate system, you can go to the origin and you can stand still. In 3, you form coordinates. And stand still in time. Time is different. That's weird. What's physics think about that? It ignores the problem. There are people, there are scientists, Brian Greene, famous one, who says, because my theory does not contain the motion of time, therefore the motion, this is not his words, the way I would paraphrase say. Therefore the motion of time is an illusion. It doesn't actually exist. Really what he's saying is if his theory doesn't contain it, it could be true. And that actually is not the way science works. We're supposed to try to account for reality, not deny it. Now here's the key fact of relativity theory that you can understand without actually studying relativity theory. Let's say the distance between you and me is 100 feet. And it's 100 meters this way, and if we go around, it's long. It's the, I hope you go. So what happens if without us moving, you're standing still, I'm standing still, and someone comes in carrying a black hole, it can be a little black hole. not a super sucking black hole, but just a little bit. And he puts it right in between, right between you and me. Then what is the distance between you and the midline of close? The answer is, it has now become infinite. This is sometimes depicted in the following way. This is a two-dimensional space. And if you go from A to B, across the middle, you got to go all the way down and back up. Infinite distance. It's short, if going around isn't so much longer. But going straight across is really long. The key thing is you can change the distance between 2 points without them moving. That's part of the relativity theory. The other thing is if the black hole didn't exist and then you make a lot of space here in the middle. Space that didn't exist before. You can create new space. And that bothers a lot of people because they think, isn't everything conserved? Energy is conserved, momentum is conserved, space? No. Space is sort of hard to get the figures on. But according to general relativity, you can create new space. In the Big Bang Theory, and much of my work in my career has been on the Big Bang, experimental measurements of the Big Bang. In the Big Bang Theory, the particles are not flying apart. In the Big Bang Theory, as written by Albert Einstein, the galaxies are fixed, but more space is being created in between them. The galaxies themselves are actually not moving in the coordinates system. They're stationary, just like you and me moving with the black hole. More space is being created inside. That may be weird, but that's what the theory of relativity is saying. If you haven't studied this, this is really strange. But this has been physics since 1916, over 100 years. That we have known this and experimentally verified much of what Einstein said. So here was the thought I had when walking on one of my weekly hikes in Berkeley. I hike twice a week, go up 300 meters, 350 meters, 8 or 9 I was thinking, well, if new space is created, why isn't new time being created? And I realized, well, it is. Every moment, new time is being created. It's what we express when we say the word now. It's a new moment that wasn't there then, and it is now. And from the Big Bang Theory, the relationship between these is just the speed of light. In the Big Bang Theory, the universe is expanding, it's getting bigger. Time is evolving. The relationship between them is given by this constant speed of light. So I thought, new space. When new space is created, you have new time. I wrote this up, put it in the book. The book was out to be published. When news came that this laser experiment in California had seen 2 black holes collide. Now, I knew enough about relativity theory that I knew that black holes have a lot of space. Let's just go out, not all the way to the infinite part, but just to the edges. A lot of space in that region. That's the region in which these gravity hit it. When 2 black holes come together, more space is created. I calculated that the amount of space being created would be several million cubic kilometers. I guess I should say 100 black from here, because I'm just learning that term. But tens of millions of new kilometers. And if my theory was right, it means new time was created. And if new time was created, we might be able to see that. So I got a colleague, Sean McGuire, to look at this with me, and we calculated what would happen. We wrote a paper, which you can get online. This is a scientific paper. The book you can get on Kindle if you want it. The pulse of gravity waves. I've studied this with great care because this pulse can be by the ordinary theory of relativity. But if there was more time created, the pulse should be shifted a little bit. And I wanted to see that. I calculated it should be shifted by about 1/1000th of a second. And I studied this and analyzed it in trouble. Turns out the uncertainty of the time is about 3 milliseconds, 3,000ths of a second. So we couldn't use this to verify the signal, to verify the theory. But I'm optimistic because this event was seen in the first few months of operation. And this device continues to operate, doesn't even have to get more sensitive. With new events will be seen. And if one of them is stronger than this, in our paper, Sean and I make a definite prediction for how this will affect the city. And the best part of it is this. Someone's going to call me up. They're going to say, Rich, we found another gravitational wave signal, and it's 10 times stronger than the other. And I'll say, yes, yes, yes. And so we were able to check your theory. Yes, yes, yes. And guess what? It's right. No, it's wrong. So nice. When you write a theory, you should be able to come up with a scientific way of showing it's wrong. And I'll go, oh, fool. Maybe use another word, but fool. And then I'll go back to worrying about saving the world, climate change. Oh, I said that anecdote. My granddaughter, who I dearly miss the way here in India, asked my daughter and I, what are we doing with this nuclear waste project? And Elizabeth came up with it. She's my daughter, and together. Well, I'm saving the world. We've just taken nuclear power, safe, and so on. It means we can stop global warming and air pollution. So it's saving the world. Layla, a 7-year-old, says, come on, Mommy, what are you really doing? And the answer she's never given yet, but it's tempted to. You're taking this nuclear waste and putting it away somewhere. You can say, well, honestly, I'm a garbage collector. But 3 months after this is all published, a colleague of mine, I'm not going to give his name because if I give you his name, you might figure out what technology he had in mind, came and he said, I think we can do a laboratory experiment to test the theory. What we're going to do is in a laboratory, I'm not going to tell you whether it's an office or a room as big as this or a room that's several kilometers long. We think there is an existing laboratory that we can use to create more space by moving masses. You don't create very much to do that, but we have a super sensitive way of measuring the time. So we are hoping that maybe even before LIGO proves or disproves this experiment, we will be able to do a measurement in our own laboratory in which we purposely create time, create space, and therefore we see whether more time is created. So I'm very excited about this. This is another wonderful experiment. When you learn this person's name, I think you deserve a great deal of credit for it. We'll see if we can do it. So that's the laboratory experiment that we hope to do. So, what have I talked about? Talk about the flow of time. Talk about global warming. Talk about nuclear waste. Talk about air pollution. I hope there have been several things here that corrected things you thought were so, it turned out they ain't. But I think it also might inspire you in your technical career. When you go into technology, you're not just earning a living, you're not just making enough money. What you're doing is something, work that is fascinating. It's fascinating, it's not just you, but your friends and your family and everybody else. Being an engineer at this level, being a scientist at this level, is a wonderful, wonderful career, and something which, when the time comes for you to retire, you're not going to want to just keep on going on. This is just, and I am grateful for being in this privileged community of scientists and engineers that have the best job in the whole world. Now, and right there, thank you very much.
Professor Richard will now be taking questions from the audience.
All right. Next. You have the microphone? I ask everybody to tell their name and stop talking.
Hello?
Yes.
Yes, sir. You were actually talking about the disposal of the nuclear waste in the United States. The question is, in India, it is different. It's a closed fuel cycle. Why isn't US going for a closed fuel cycle? Why is it, kind of like storing the waste instead of going for,
Yes, another question. Question, why not separated and so on?
Yes, because you can actually reprocess it.
Yes, you can. And the reason is it's cheaper now.
Yes, that's a very convenient answer.
It is, very convenient. That's why we should do it too. Because you can't afford to throw money at something that doesn't need it.
Okay.
You can reuse it, but storing it underground is so simple and straightforward.
So
There's no need to reuse it. And what you need to do is continue your economic growth. And that means getting your power as cheaply as possible.
So, following up that question itself, the fact is, US is quite a developed country. Now, you are saying, which is actually true, that the developing countries, even though there is an economic growth, there is always a chance of air pollution. We can stop using coal, but how can US or Europe or any other countries help these developing countries to develop such cheap technologies so that we don't have to go, for coal or something to
First of all, India is perfectly capable of doing it. So you don't need our help.
That's also convenient answer.
It's correct. You can do it on your own. Should the U.S. help? Should the U.S. help? Of course, we should help in any way possible. Have we been helping? No. Why haven't we been helping? Because the government of the United States has opposed nuclear power. It has opposed shale gas. It has opposed 2 of the 3 solutions. That's why we're not helping. We're not helping ourselves. We're setting exactly the wrong example. We should be going ahead full speed on nuclear power just to show people that yes, this is a good solution. But quite frankly, you don't need our help.
Okay. Thanks, sir.
No question. What about the phone? Okay. You're using a question time. You're there? We're pretty close to you now.
Only the northern India.
Okay.
Only the northern India. Not in the southern India.
The very south is pretty
Okay.
clear.
Yeah. So, and this is also because of the geographical feature of the northern India. Because at the southern part or at the bottom you have the hilly region, and at the northern part also we have the Himalaya. So that basically restricts the advection of the pollutants. So that's one thing. Second thing,
Let me answer that one first.
Yeah,
Because I tend to forget questions when you ask what you want. Respectfully, I disagree. We'll basically large on my experience in China, where everybody says the basins collect the basin around Beijing. Beijing doesn't have the highest air pollution in China. The pollution in China comes from the south. There is no correlation between the basins and PM2.5 in China. This idea that it's collecting is something which, when we look at in detail, doesn't seem to be the case. The south, why is the south of India worse than the north? There could be many answers to that. It still is pollution, and certainly geography plays some role in this. But beware of the statement that you can explain it from the basins, because when I look at China, it really doesn't correlate with the basins at all. So we haven't done it so carefully with India, but be cautious. Just don't run into it.
Yeah, so we can see actually like during the winter time, a blanket type of formation is happening because of the shallow boundary layer also.
The boundary layer is what comes.
Yeah, the second important aspect which I want to.
Is that a question? The boundary layer, was that a question?
No, I'm just
okay.
putting my views. The
Yes.
second thing is that of the PM 2.5, we have tremendous measurements, and that provides us the information that nearly 70% of the PM 2.5 is scattering species.
Is the what efficiency?
Scattering species like organic matter, sulfate, and nitrate. But the remaining 30% is comprised of mineral dust and black aerosols, black powder. So we have tremendous amount of the organic aerosols, and therefore we have been suggesting that the all radiative forcing models must incorporate the organic aerosol, which is a massive source of PM 2.5 from biomass burning emissions.
So what is your question?
So the thing is, in that light, you have shown the emission scenario of PM 2.5.
Well, certainly a large fraction of PM 2.5 comes from coal burning, and that can be eliminated.
But we have been seeing that it's from biomass burning, which is a very...
Well, there's a huge amount of biomass burning.
Yeah.
On the other hand, biomass burning, I suspect, is not as dangerous as coal burning. We now categorize all PM 2.5 as the same part. We know for sure that's not the case. Certain types of PM 2.5 are not as dangerous as other kinds. My own guess, and we haven't verified this yet, is that the PM 2.5 coal, with the SO2 component, is probably the most dangerous one. The biomass burning, even though it smogs up the air and hurts your lungs, may not be as dangerous. So this is why I'm concentrating on coal as another question in the back. Who stood up?
Hi. So my question is relating to the US, not to India.
Okay.
So you all know recently Donald Trump became the president. So where do you think the research, etc., is going to go now that he is, for example, now that he has put Scott Pruitt, somebody who is known to go against EPA policies, as the head of the EPA. So what do you think is going to happen in the near future?
Well, the reason Scott Pruitt was picked was because Donald Trump believes many of the EPA policies were ill-advised. I have to agree on that issue. I mean, I didn't vote for Donald Trump, but the attack on natural gas, for example, because it is a fossil fuel, I think was really a poor decision. And many of these things do need to be changed. We'll see what actually happens. But I'm somewhat optimistic because natural gas and nuclear are two parts of the triad of the solution for the court. And both of them are favored by Pruitt and Trump. So I don't want to defend Pruitt on all environmental issues, but on this one particular issue, I think we may actually get a benefit from. Now let's see. Question from.
Excuse me.
Go ahead. I don't want all the questions to come from the little people. Pass the microphone back to Prof. So.
I have a question.
Okay.
What do you mean,
sir? Someone get a microphone.
What do you mean, sir? Okay, sir, so I'm a big fan and my question is a physics related one. So, sir, can you please explain the tachyon-murder paradox? You discussed it in the new book, The Theory of Time. The tachyon-murder paradox.
Okay, this is something that appears in my book. And tachyons are part of the atomic density of light. And every now and then someone reports one. There was a concern a couple years ago. They'd actually seen something goes past the speed of light. And when I said that, I don't really, why not? Because I have a prejudice. Yes, I have a prejudice. I have a prejudice that fits me to not work on tachyons. The prejudice is based on quality. So most tachyons exist in atomic density of light. I do believe in special relativity theory. It's been tested in so many ways. I have tested it myself. I've seen the this mass rise. I've seen time dilation in my own laboratory. Special relativity is right. If we have a tachyon, let's say someone in the audience shoots me with the tachyon and kills me. Hypothetically. There is a frame of reference in relativity theory in which I died before he pulled the trigger. That's true. Now, does that violate physics? Well, what about causality? Well, if you believe there is no causality, that the person who pulled the trigger had no choice, because we are not really, we don't have any free will, then there's no paradox. I died and he pulled the trigger. His defense in court was, but he died before I pulled the trigger, you can't pull the trigger. the solution to this problem, in my mind, is either to abandon free will, and the person pulling the trigger had no choice. Because all the forces of the universe that killed me forced him to pull the trigger. You abandon free will, or you deny the existence of such particles. So since I, part of my religion, I believe in free will, I'm not going to waste my time looking for particles that don't exist. If they do exist, then I'll be disappointed. It's fascinating to me that an issue such as a tachyon can actually relate to a test of free will. Tachyons exist, and relativity is right, and free will doesn't exist. Example of the tachyon effect. But that's what I made that up, and I hope it was smart. Will not waste my time. Okay, there was a question for it.
Hello sir. So sir, I believe that Al Gore in a TED talk says that one of the major cause of global warming is in fact not coal burning, but rearing of animals for food. Because the amount of greenhouse gases that are generated are humongous in that. So I was just curious that is it true that like, if the whole let's say goes vegetarian, then the global warming will not be a problem anymore?
Okay, I would argue no, based on the fact that all food is basically carbon neutral. It absorbs, whether you absorb carbon dioxide from the atmosphere, it goes into a plant. You eat the plant, carbon dioxide goes back out when you breathe. Or an animal eats the plant, you eat the animal. But in the end, it's carbon neutral. The same amount of carbon dioxide goes out in the atmosphere as came in. So whether you have, I mean, it may be wasteful from a hunger point of view. You can feed anyone people with vegetables and you can meat. But in terms of global warming, they're both carbon neutral. It's like biofuels, they're carbon neutral. You grow them and you burn them. But there's no net change in the carbon dioxide. Food, whether it's meat or plant, is carbon neutral. Next question. Where's the mic? Or someone did hand the mic. Oh, sorry, you were handing the mic. Yeah. Okay, maybe I'll let you people hand out the mic.
Hello, sir. I have a question that what is the contribution in the global warming and air pollution that causes due to the atomic bomb explosions and the weapon explode in the world, maybe after 1945? Maybe after Second World War. Maybe after Second World War.
Yes. Well, there were these atmospheric atomic bomb tests. And what they did is they made a spike, a big increase in the amount of energy. Yeah.
But they didn't really change the amount of carbon in the atmosphere. So, and the amount of
Heat was tiny compared to the amount of heat that hits the Earth during the day. Those are temporary effects, and the net effect of them on global warming is negative. Somebody what around the world? Someone put this mic away from them. Wars around the globe. Well, I actually believe that there are wars around the globe that has been going down. The wars have been more than they've been little ones. And you want the effect of down warming? I like what Rosemary once said to me. The best way to prevent war is to require anybody who wants to fight a war to have to file an environmental impact statement. I don't think. The big thing in global warming is clearly the extent that means we burn more fossil fuels, then that increases global warming. But war is actually a small part of the economy, and it doesn't have that big of an impact. The next question.
Due to time constraints, we won't be able to take all the questions, so there will be just one last final question.
Hello sir. My question is a bit off topic, so I would like to ask, you might be knowing the deep space travel will be quite a need of human civilization in the future. So for that, we are going to need a whole lot of new kind of fuels. The kind of things that can accelerate spacecraft to such enormous speed so that we can cross the distance, the distances that so we have achieved by the spacecraft that we have built till now. So I would like to ask you what are the possible developments that could take place in this field, and what is the role of a physicist in doing this work?
I'll give two answers. The first one is, I don't need to negate your question, but I don't think we're ever going to want to go through another struggle. Not for thousands of years. We live on a planet in which living under the ocean on the sea floor is tremendously easier, cheaper, and safer than going to Mars, for example. And we go to Mars because it sounds like an adventure. How much money do we spend on adventures? Well, I don't think we're going to do this. But the second question is, if we wanted to, how would we do it? And my thought is, slow and steady wins the race. So, for example, let's forget relativity theory. Let's just talk about ordinary physics, because you don't have to get into those details. Suppose you accelerate at 1g. 1g. So when you're standing on the ship, by the way, I believe that in Star Trek and in Star Wars, they're always accelerating at 1g. That's why they can walk around the station. They have a 1g acceleration that gives them artificial gravity. So they don't even talk about it because they take it for granted. Just like you take for granted having a horn on your car or brakes. So they have this 1g acceleration to walk around on the spacecraft. So if you accelerate for 1g, classically, in 1 year, you're traveling at the speed of light. Just work out the number. So slow and steady wins the race. Accelerate at 1g, it might take years to get there anyway. And pretty soon you're getting up to close to the speed of light. Now, how do we do that acceleration for 1g? Having the fuel with you is kind of hard to do that. So either you pick up fuel on the way from the space, or someone shines a laser at you and accelerates you externally. And that's a fascinating technology. There's several companies that have looked at this for launching vehicles into space, where instead of putting the fuel in the rocket, you simply shine a laser at the end. And you can use heavy fuel, which then is more effective for accelerating you. So that's one possibility. Moving around the solar system, I really like using solar sails, solar wind. Those are really good technologies, and those are ones we understand. These are big, large structures in space, but I think those will happen. And to go really fast, we want to have very high, specific energy, which means the fuel has to go out at very high velocity. And so building in some sort of an accelerator or plasma device that will shoot out higher particles will also enable you with high efficiency to get the high speed. I don't know. I'd say what you're on.
So one more thing that I asked, like if someone would like to work in that field, and so what would be the role of a physicist? Like engineers have particularly a role in building all those things. So what can a physicist do?
Okay, I don't think there will be any jobs in that field because there's if you want to get into that field, you really have to raise the money yourself. There are people around who are billionaires. Go to a billionaire business that you have inside an idea and ask them not to check with me to see whether the idea makes sense. Sorry. Okay, good. Thank you very much.
On behalf of Team Techkriti', I would like to extend a warm handshake to Dr. Muller, and I would like to invite Dean of Student Affairs, Mr. Girish, to present a token of thanks to Mr. Muller. A small announcement, all members of Techkriti